Hi, my name is Jimmy Guo, and this is my video lab report for Physics 2211, Lab 4, Oscillations. The purpose of this lab is to compare two different models of Python glow script and tracker analysis. We then analyze the graph of different kinds of energies. The system is the Earth, spring, and mass, and the surroundings is nothing for this lab. The main results are that the predicted model and observed model are similar, but the x-axis is more similar. And more importantly, the change in total energy is zero. The key ideas relevant to the lab is Newton's second law of motion, from which we can derive the velocity update and the position update formulas. We'll also be looking at two forces in this experiment, which is the force of the spring and the force of gravity. We'll also look at the energy principle, which states that delta E of the system is equal to work done by the surrounding plus heat. There is no work done by the surrounding on the system and no heat transferred, so delta E of the system is equal to zero. And delta E of the system can be split into the change in kinetic energy, change in gravitational potential energy, and the change in spring potential energy. An assumption that we had to make on this lab was that the drag force on the mass was zero. Here I downloaded the video from Canvas and put it into a tracker to analyze the motion of the mass. Before doing so, however, I started off by putting the correct axis and getting the calibration stick to 0.7 meters, which was given to us from the pre-lecture videos. Moreover, I had to make sure the frame started from 5, which was the moment the mass was about to be dropped from the hand. Also make sure that the frame dt was 0.0959 seconds. 95 seconds. After setting all the necessary inputs in the tracker, I plotted the motion of the mass. Here we see a graph in the direction of both the x and y axis. In the glosary code, I coded the initial conditions using the information we got from the tracker app, which tells us that the initial position is negative 0.12, negative 0.656, 0 meters, and the initial velocity is set to 0. Moreover, we know the mass from the pre-lecture video, which was 0.402 kgs. Here I also changed the dt to be correct, which is 0.095 seconds. Here we see that I changed the spring constant to 9.83 and the L naught to be 0.123. In the bottom, I calculated the three different kinds of energies using the energies formulas for each of them. Here I had to find the net force on the object, which was found by adding the force of gravity and the force of the spring. Using that net force, I was able to use the velocity update and the position update formulas to get updated velocity and position data. Using the new updated data, as shown in the bottom, I was able to find the new energies for the three of them and calculate the delta E energy for the three individually. After getting all the information, I graphed the data using an Excel spreadsheet. Here we see an energy graph that shows that the total delta E is constant, which equates to 0. However, in the other graphs, we see a graph that resembles a sine function. Here we do see some errors in my delta U spring graph, as it is not a perfect graph. This may be due to not accounting for the drag force within the experiment. To account for such error, we can conduct the experiment again and include the drag force. Here, when comparing the x and y axis, the predicted model and the observed model are very similar, but the x-axis is more similar than the y. In short, the answer to the first question is yes. As we saw before on the energy graph, the sum of all of the energies is equal to 0, and the total delta energy is equal to 0. This is also shown before, as since there's nothing in the surroundings, there's 0 work done on the surroundings, so the delta E of the system is constant, which is 0. And here I calculated the period of oscillation for both the x and y axis. This is done by looking at the x and y position data and finding the time it took to get from one peak to the other. The x position oscillation was about 1.73, and for the Y position was about 1.52 seconds. Such difference in the period of oscillation may be due to the drag force that is not taken into account. Thank you.